That's all. Like each of the values are around the center. The curve is bell shaped.
Okay.
It's symmetrical, and we can get the observations with the standard deviation. Like 65% of the data is on the
95 and 89.7.
Those numbers are also important because suppose if I'm talking about the normal distribution, numbers are most important, friends. Okay, that 68, 95 and 99.7. Okay. So, and what is the relationship between mean and standard deviation in the normal distribution?
Empirical formula which goes with mean plus or minus 1 standard deviation, 2 standard deviation, and 3 standard deviation.
Oh, okay. Right. So here in the normal distribution, what we have observed, friends, basically if you refer the normal distribution, what is the first principle we have to showcase in the, suppose if I'm using the normal distribution?
Mean, median.
That one actually, mean, median, and a mode kind of things. These should be coincide. What is the second one? Symmetric. The graph must be symmetric. This is one more important thing we have to see. And there is a empirical rule, friend. Next, empirical rule. What it says is the empirical rule basically giving the aspects of 99.7. These things are giving us. There is one more formula actually. So like mu plus or minus 1 sigma, mu plus or minus 2 sigma, and mu plus or minus 3 sigma. Okay, so accordingly you can correlate the kind of the data. Okay, these are all the things we have observed in case of the normal distribution. Suppose if I am interested in the non-normal distribution, so maybe I cannot say always we'll be getting the normal distribution kind of thing. We are making use of the non-normal distribution also. What do you refer in this case, friends? Non-normal distribution.
Chebyshev theorem.
Chebyshev theorem. What it says, friends, actually, what is the analogy behind that? 1 minus 1 by k square. This is the formula. So there we have solved some kind of the analogy. We are not having any particular usage of these kind of aspects. So you can make use of that Chebyshev theorem. Now, which are all the two important parameters playing a vital role in normal distribution? Because in interviews also, friend, they generally ask, if I want to work with the normal distribution, maybe 1 or 2 questions might be there. See, the division is like this, friends. Suppose in case of machine learning interview, if you are attending, okay, so very simple. They will initially check you the algorithms, whether he's knowing the algorithms or whether he's having confident enough on the algorithms. This is the first thing. 50% of the score is given to that one. Second thing is your confidence levels, and as well as your vocabulary related to the ML landscape, because this they consider as at least 10%. And remaining in sometimes, friends, at least you should know what do you mean by data frame. Okay, what exactly the train test set. Okay, so what is a model? These coding kind of the aspects. Okay, so it can be 15%. Clearly they will distinguish. So it becomes 75, and remaining aspects, so the remaining aspects are maybe specifically any Python or any SQL kind of things, or else your domain expertise. Okay, all these kind of things, some 10%. And finally, the confidence levels already have given. Finally, the domain knowledge, friends. Maybe if you are working in the banking domain or retail or insurance, okay, whichever. So 60, 75, 85 and 15%. Like that, the division would be there. So you should prove your strength. Maybe you are very much familiar with the algorithms, and if you want to score more marks on that, because there is some kind of interface, and within that interface we need to feed the data. Obviously, if you are scoring some 50% overall, then you will be shortlisted. So based on that particular convention, you can follow up, friend. So for one or two interviews, maybe you will be getting the fair understanding what the interviewer expecting from the role, and moreover based on your experience also, friends. So if you're putting more 10 or 12 years of experience in the machine learning, and maybe relevancy you can put like SQL and Python you can put as a background. And other than this, if you are putting any other thing like Java, they may not ask questions, friend, because it is purely related to your Python orientation, and as well as sometimes, you know, if you are maybe they want to check your big data skills, like whether you are knowing about that thing, because as I mentioned earlier, especially in case of the machine learning and data science kind of the orientation, we always get the data from various sources. Okay, maybe that is the ETL based scoop, or else sometimes some SQL relevancy kind of Hive. Okay, it all depends. Good to have those kind of things also, friends. However, in the last 5 sessions, I'm going to give the complete narration of how the companies are expecting and how to exploit the knowledge of this particular algorithms, and all these things I will be covering things. Okay, those things. And apart from this, they may mix up the stat orientation here, friends. In stat, I didn't mention. So if you see the stats, maybe it is not individual component, maybe along with your subject matter expertise, that means the domain knowledge or subject matter expertise, how we are explaining the scenarios. Maybe they may ask you, where do you use that dimensional reduction? Can you give the scenario? And where you have created a new feature, engineered feature, can you give the scenario? Or else maybe standardization and normalization. Okay, so friend, one more thing, if you want to write some papers, and if you want to become a researcher, and if you want to apply for Amazon and Facebook, definitely Kaggle greatly helps you. Okay, so that you can extend and enlarge your mind, and you can apply for those positions, because data science and machine learning positions are a bit distinct. So let me give some insights of that, what exactly the companies are looking for. Maybe I will give a chance of talking about this thing. However, I got the chance of explaining these aspects to you. Spend some time, friends. 1 minute. Yeah, just to see and comment your observation. All in the call, maybe some other person. I'll Lakshmi, Akash. Who is Akash? New member or Akash?
Yes, sir. New member.
Akash Sajjan. Akash, how are you?
Fine, sir. You, sir?
Yeah, I'm well, Akash. Now, when you have joined, Akash, by the way, today.
Yes, sir.
Now, hope you got the recordings and you are going through those recordings
Yes, sir.
also.
Yes, sir.
But this is the 32nd session, Akash, and maybe okay, no problem. With your background and with your hard work, definitely we can reach these members. No problem. Okay, right. Go ahead. Very good. Welcome, Akash. Welcome, and do well.
Thank you so
All
much,
the
sir.
best.
Thank you, sir.
Good, Akash. Nice. Lakshmi. Yeah, Lakshmi, how are you?
Yeah. Yes,
Yeah,
ma'am.
yeah, I'm bored, Lakshmi. Actually, these two guys, Venkat, Suresh, and with Yogesh, we are like some kind of friendship has been developed between us. and I am bored with these guys. Okay, I am asking you to explain this diagram. Maybe if I am giving chance to Venkat or Suresh, again they consume my entire time. They they explain more, so that I want to cut down the time and I want to make use of the time for other topics. So just to think through and just to give a just understanding what you have observed from this diagram. You're saying something?
These are, I mean,
Okay.
different perspectives of.
Different perspectives. Okay, not the originality. Okay, right. So if you see the first category, society is thinking that the data science or machine learning members are doing everything in the planet. So maybe they need to design the robots and they have to work with everything, all the problems, even the higher potential government employees or members are come to us and
Umar, you're not audible.
okay, now hope I'm audible. Yeah. Okay,
Okay.
friends. See, the perspective, as our friend told, the perspective is different. Whereas what my friends think I do, because just if you observe, he is very much close to the robots, and like he is going to design the robots and he is going to perform the robotic kind of the functionalities or embedded systems. Their perspective is like that. And of course, parents always think through, even after sending his kid to school or college, they feel that all the questions raised by the faculty members was answered by my kid only, and he is the Superman. That is a general perspective. And similarly, if I'm saying in my home also, my parents feel that, okay, he's doing everything in the office and he's a data scientist or machine learning engineer. Okay, so parents thinks that he's a very properly arranging everything and he is managing everything in the office. Now the other programmers friends, maybe from the background of maybe if you are talking about your Java friends, maybe the persons from SQL or PLSQL kind of the background, or even mainframe guys also, they feel that, okay, this guy is working with mathematics or statistics, because programming wise, if programming is the demand of the machine learning or data science, then I also become a data scientist kind of thing. And what I think I do, because that is also important. What we are thinking about our position, we always think that that some kind of heavy visualizations would be there, and I need to convert a kind of logics into the programmatical perspective, and I should produce the results to the functional users like that. But what I really do, and some other session friends, I I got a strange question. Actually, that guy asked me, like, do we need to create any ML algorithms ourselves, and we need to you apply some kind of new algorithms which are not exist so far. See friends, here machine learning or data science is a field which provides us some set of the algorithms, and what we are doing is, according to our requirement, we are trying to make use of those particular algorithms in our workplace. Okay, so personally, so suppose if you consider my case, I am making use of the machine learning algorithms or some kind of the optimization techniques both in my workplace and as well as the teaching and as well as in my research also. Maybe my perspective is a little bit different when you observe your perspective. Okay, so in this batch, maybe if researchers are there, then they can have the writing of the papers or publishing of the papers by getting some kind of the results, or they can even compare the performance aspects, and they can suggest the better methodologies so as to apply the kind of the algorithm. So the final aspect here is, the expectation here is, friends, just whatever the aspects we're having. Suppose if I'm considering the supervised learning, there are certain aspects we're having. Okay, so in case of that supervised learning, we are having all the classification and regression techniques, and there we are going to apply some kind of the methodology. Like if my requirement is to consider the weak learners also, and if I want to apply some conditional probability, obviously I need to go with the naive bias. Whereas my demand is not the one dimensional or two dimensional kind of the data, maybe some different dimensions, 3 or 4 dimensions data would be there. And in that particular case, I want to apply some kind of the techniques like kernel based technique. I should use the support vector machine. Whereas in my situation, okay, the requirement is like this. So I want to make use of some kind of the decision making, or maybe some conditions or applicability of various levels of the kind of the conditions. It's not the one or single condition, multiple conditions would be there. In that case, I can go with the decision trees. Okay, so it all depends, friends. Okay, so we need not go and design or create new algorithm. That is the first point. Second important thing is, it is all that magic I told na. So you need to have that magic. That magic is nothing but maybe a selection of the proper algorithm and fine tuning of the parameters, and immediate launching of our stat capability in the team, and supporting our team by providing the proper inputs of in the data pre-processing or feature engineering. All these things are that magic, friends. So don't feel that only learning of the algorithms or implementation of the code definitely survive me. No, along with that, of course, you can with without coding also, many members in the teams with their capability of stat and with their capability of domain knowledge and with their capability of storytelling, definitely they are adding value to the team, friends. Okay, sometimes, you know, in the client meeting, if I am talking about the kernel tricks and conditional probability, they may not get into the track, but the persons like Suresh or Venkat, you know, though they are having the technical knowledge, they can able to fetch and they can able to generalize the things, because from manufacturing domain or from SQL or database kind of the domain, they can talk in their language. That's what I'm trying to say. So it all depends, friends. You need to showcase whatever the talents you're having, which is nicely enlarged into your team requirement, and you can play the role of a data scientist without any difficulty. Okay, that is what you know, maybe people expect more, friends, not your team or not your company, but your friends may expect more, or your parents may think they may not expect, but they think through, like my kid is doing everything in the planet, and where other members are not at all doing anything, and he is the messiah of entire planet. Okay, so and one more thing is, you know, so the other programmers, because they are also curious, but they are not into the data science or machine learning kind of the domain, but still their thought process is, you know, he's doing all the math or stat and along with the programmatical kind of things. Okay, so this is a glance actually. Okay, however, capabilities are dependent on the change from person to person, friend, but expectation, now you see, even the from the background of the Microsoft, from the background of the Infosys, and even I observed from the background of the TCS, all the members I have interviewed in the past week, friends, I reveal a secret to you, and even they are not aware of all the things also, and they are fairly saying that we have not used that aspect. I simply asked, okay, so because I am interviewing them for the PySpark orientation, and I asked them how to submit a Spark to the ARN cluster, and they told that we are having a team, okay, a deployment team, and that particular deployment team is taking care about the submissions with the DevOps or some other teams, and we hardly use the local mode of the submission. See how it doesn't mean that if he is not knowing the deployment, we are not going to recruit him. No, friends, not at all. Because just out of curiosity and to know the understanding of how they are submitting the jobs and how they are performing in their thing definitely matters. And it doesn't mean that you should know every hook and corner and you should answer every question. No, not like that. Okay, but only the thing is some basic things would be there. And if you are not knowing about supervised and unsupervised, and if you are not knowing about optimization techniques, and if you are not aware of your conditional probability, at least in the Bayes theorem and naive bias, then you will be in trouble, friend. So because they're all the fundamentals, and they are all the bare minimum expectations from any machine learning or data science person. Okay, so that is what how you can, but definitely in the last 5 sessions, I'm going to give you the complete narration of the interview aspects, and we will pull all the best practices in the industry, and all these things we'll do. Okay, rather than a typical course kind of thing, we'll see the practicalities and all the aspects. Okay, now one more important thing I want to ask you. So we have seen some distributions, and we observed various aspects related to normal and as well as non-normal kind of the distribution, and there we felt some kind of observation. Okay, so now just I'm giving a diagram, friends, and just you can comment on that. This is open for all. Maybe Suresh and Venkat also, Yogesh also can participate. Yeah, what is your observation from this?
He is giving the data between all the between those standard deviations.
Okay,
Standard
so that
one
means
to one.
standard deviation is different.
Yeah,
Mean is same, na?
mean is same.
Mean is same. Okay, so I want to convey one information. Like this diagram is not new for us, friends, to be frank, because in empirical formula also, more or less we have seen the same kind of the diagram. Na? So just one diagram we have seen. So there, you know, friend, just we're having the standard deviation different and mean value is same. So if you happen to see this kind of the diagrams, you need to observe that, oh, this diagram and this distribution mean is same, and we're having different kinds of the standard deviations. Okay, now if I'm asking you guys to have a look on this diagram, just have a look on this. What is your observation?
Same standard deviation applying on different means.
Yes, that means I'm having the same standard deviation, but my means are different. That means, friends, you see here in the first diagram, if my mean is same, but my standard deviation is distinct or different, then I'm getting this kind of the observation in the distribution. Whereas if you are observing this thing, friends, see, we're having some mean values different, 15, 25, and 35. And we are making use of some kind of the standard deviations. Okay, same standard deviation is running through all these different kinds of the means. So this is the diagram how it look like. And the third always, what is the third model, friends? What is our third model? Generally, the two possibilities we have seen. What is your third model?
Both are different.
Both are different. Okay. The observation here is, okay, so my mean is distinct and my standard deviation is also different. Now, if you see the second diagram and third diagram, what is the common property, friends, in these two? So standard deviation, if it is same or different, we are getting this curvic nature, friends, actually different curves. Okay, so whereas if your mean is playing a vital role, Okay, just there is a overlapping of the corresponding curve. Just to observe that point. If your mean is same, standard deviation is distinct, then all the overlappings happens, like empirical rule can be applied. Whereas if you are talking about the different means, definitely I cannot expect okay the same kind of the overlapping on top of these diagrams. Okay, and the third one also never mind, like in this particular case, even we are not expecting the same kind of the mean or same kind of the standard deviation. If that is the case, then how these particular things are behaving. So this is how you can observe the differentiation between same mean with a different standard deviation, different mean with the same standard deviation, different means, and as well as the different standard deviation. Now, let me ask you this question, friends. Okay, we have seen some kind of the examples. Now I am asking you, don't be in a hurry to answer first. Okay, so just to observe it. And my question here is, friends, whether or not the below two distributions are equal or not. Below two distribution in the sense, this shaded area, this area 1. Yeah, however, I mentioned this area 2. Whether these two are equal or not. Just to observe that, just to use the knowledge of your earlier sessions, and you pull all that observations we had in the earlier sessions, and you can give the answer. My question is whether these two shaded areas are equal or different.
If you start applying the formula here,
Which formula?
mu plus yesterday you told mu plus k sigma, which is which gives you the higher value of the mean values from low to high. If you take the higher value of the mean, and like yesterday you were talking about something like 29 to 49. One example you have given.
Okay.
mu plus k sigma is equal to.
Do we need to really pull k here, Suresh? Just to observe that.
No, actually.
Both 1SD, we can apply directly the percentage 1SD.
Why Venkat? Your answer is correct, but I always says the process you follow. Yeah. The answer is correct. The both are same, friends. Answer is correct. Yeah.
Here standard deviation is mentioned as 35. So 100 to 135 is that is one standard deviation, and the second case 60 to 90. We have given the standard deviation is 30. So 60 and 30, the 60 and 90, the difference is 30. So when I see the data will be like what we have seen off of the percentage.
Excellent. Like that is the point, actually. Very good, Venkat. See, you are really on the pace, actually. So I appreciate that. See, the analogy behind this, friends. He has not only given the right answer, and the process he followed is also simply good. Okay. See, no matter, friends, whether how much mean I am having, how much standard deviation I'm having, leave that. Only the thing is, our interest is whether my mean is equal to 1 standard deviation, or whether my mean equal to 2 standard deviation, or it is equivalent to 3 standard deviation. Okay, now from this diagram, friends, you can fairly see that here the standard deviation is 1 only, because it is 100, our mean is 100, and it is distinct with 1 standard deviation in the diagram 1. And in diagram 2 also, what is the mean of that diagram 2, friends? Maybe whatever the mean, this is mean 1 and this is mean 2, and simply we are having the standard deviation 2. This is the diagram 2. Now, as per our friend analogy, so what is the percentage of the data between the 1 standard deviation of diagram, friends? This is lies in 68%. This is also lies in 68%. But which half we are talking about, whether positive or negative side?
Positive, sir.
Positive side, because we are taking this 35 and it becomes 135. Definitely it is a positive standard deviation, that too positive 1 standard deviation. Okay, and if I am considering the 68% of my data and I am dividing this into the positive thing, so that obviously we are getting the outcome which is same for both the diagrams. Friends, is it clear?
Yeah.
Venkat, very good, Venkat. Maybe Suresh is also, Lakshmi, or all the members in the call got the same insight. But that spark is important, friend. Maybe you may not give the exact, the fastest finger or fastest answer.
What has happened is the answer is no. But on the other day, you caught my neck and you said that you need to go with a verification. So I was just
you are applying that, but see the
that is the reason that I didn't tell the answer.
Simple thing.
The answer I know.
Suresh, one thing, let me tell you this. Yogesh is a good observer because sometimes he speaks. Lakshmi is a good observer and she's having very good intelligence. And in your case and Venkat case, I can say one thing. Venkat is very slow, but I strongly recommend adopt the Suresh curiosity in answering. And Suresh is very curious, but he's very, I don't, so that as a curious, but you are always try to give the very sharp kind of the answer. So if you exchange your thinking, like how Venkat is doing, thinking and taking some time, if Suresh is having that property, definitely you are ultimate. And Venkat, what he has done is Venkat nicely got your he only said one time, and that week you were absent for the sessions. Meantime, he picked up and he has come to your zone, Suresh. He has completely proxy for Suresh nowadays. Okay, that is only the observation. Okay, right. So, and coming to the other example, let me pull one more example, friends. Let me talk that thing. Hope you can give the answer for that. You should see where I kept that particular diagram. I thought of taking one more diagram. So let us pick that particular diagram, because it is always good to observe the kind of a narration while dealing with the these kind of distributions. Okay, so distributions always give some kind of the idea, so that we can have the understanding of what exactly we are trying to tell to our team, or what exactly we are trying to implement. Now you see this diagram. Have a look on this, friends. I got it. Yeah. Same question, whether these shaded area both are equal or not. I mean to say the percentage of the data. You have to think through that, friend, because if I'm asking something, definitely there should be some kind of the trick.
Here he is giving the whole. He wants the whole, so we don't divide. It's coming 100%. Two standard means it is 95%.
2 standard we are getting. Coming to the first diagram, Suresh, what is your analogy? 2 standard means it is whether in a positive or what exactly, or 10 to 50.
But he didn't mention it as a positive. It is showing on the both sides, no? No.
From this, from this 50, if you are seeing, left side I'm having and right side. Okay, you are right. Plus or minus 2 sigma. Okay.
2 sigma.
Because our mu is 50, and as he is saying 2 sigma as 40, definitely sigma should be 20. Okay, na?
Yeah, sigma should be 20. Yeah.
20. Sigma is 20 in both the cases. Okay, so that as you rightly mentioned, it is as there is a chance of moving this particular standard deviation to left side and as well as the right side, we are having the plus or minus 2 sigma. That means 95% of our data is spread over 2 from 10 to 90.
10
Agree,
to 90.
agree friends? Agree? Because 10 to 90, whatever the scale we are having, our 95% of the data lies in this particular area. Because as per the empirical rule, we are having 1 sigma, 2 sigma and 3 sigma narration. Of course, 1 sigma, earlier example we have seen, and now we are talking about the 2 sigma. So just it is giving the 95% of it. Leave that 50, 20. We are not interested on that. Only our interest is whether these two diagrams are scoring the same kind of the distribution or not. Whether this
You want
particular...
to see the data is lying between 2 sigma.
That's all. That's all.
Whether it is in the 95%.
Yeah, that's it. See, Suresh, one thing. If you are not having empirical rule, then what is the problem here? If no empirical rule is there, simply we were given some normal distribution analogy, then do you think can we have the meaningful understanding of these diagrams?
You will not have a meaningful understanding.
Never.
You'll stuck.
Yeah, you'll stuck. And one more thing, you told one example that calculation of 1 by 1 minus k square. We have to bank on this kind of thing. Okay, but that too, this is for the non-normal distribution. If your distribution is normal, and if you are not having the empirical rule, nothing can be done. Okay, and there we cannot get any insight of this particular data. And similarly, the second diagram also same na. What is your 2 sigma? Starting from the 140, it is moving to 200, and of course it is moving to 260. Of course, they clearly mentioned that our sigma is 30 in this case. So 2 sigma obviously becomes 60. And if I'm talking about my mu plus or minus 2 sigma, which is again 95% of our data. Okay, so this is how you can specify the orientation, how we are making use of the convention related to usage of the sigma and as well as the standard deviation. Okay. Now, friends, one more important thing, most commonly used kind of the terminologies, which are nothing but the statistical tests. This is probably the last topic in the statistics we are going to talk, and from the next session onwards we are going to deal with the launching of KNN and implementation of the KNN. Okay, all those kind of things. But before coming to tomorrow's session, I'll definitely give some kind of the task to you guys. So just go through, and before coming to the session, just to have a look on that. And if you are having any doubt, then first I will clear those doubts and then we'll move to the discussion of the implementation. Now, coming to the statistical test. So suppose while performing any activity, friends, we have to quantify the results at any moment, you know. So suppose if I want to work with some kind of the statistical measures and I want to perform some kind of the activities, I should observe what exactly my requirement and what I can expect. What do I do with that corresponding data item? So in that particular case, we are having the very first methodology, nothing but the Z score. Okay, so just observe here, friends, the Z score. What I will do is, first I will give you some kind of the representation of the Z score advantage, or what exactly Z score is doing. Then you can come back and we can come back and define this particular Z score. Have a look on this particular diagram, friends. This particular diagram is the outcome of the Z score. Have a look, don't think much, nothing complex is there. Let me see how many members are thinking in a simplest way, and the members who are not making the complications out of the questions definitely hit the answer, friends. No doubt about that. Don't overcomplicate the things. Simply, we can have a look on that, what exactly that diagram is trying to say. Venkat, can you give a try?
It is just 2 minutes.
No problem. Go ahead. No issue. Akash, you also. Lakshmi, whoever. No background, nothing is needed for at least for this concept.
It's just the difference between the input value or the feature, like feature and the difference between the mean and the feature, and then dividing by standard deviation.
We will start from this Venkat, minus 25. What is your mu value? 50 divided by what is your sigma? 25. That means minus 75 by 25. What is the value? Minus 3. Similarly, minus 2, minus 1, 0, 1, 2, 3. Agree, friends? See, our Z score or our Z value is simply giving some minus 3, minus 2, minus 1, 0, 1, 2, 3 kind of the outcome. Okay, from the available data or from the available distribution. Now, what is the observation from this diagram? Is what exactly the Z is doing here?
For every, it is incremental of a standard deviation, minus 25 to 0, and then 25, 50. It's just a increment in every step.
So, which provides a standard score, okay, which indicates what exactly it is indicating, friends? Indicates how many standard deviation an element is from the mean. Element from the mean. Okay, very simple. Now you tell me one thing, friends. In data pre-processing, what do you mean by data pre-processing? Suppose I'm giving this scenario, like I'm having age between 20 to 80 years people, starting from the interns in my company. I'm having in my entry, and we are having different members, you know, starting from the age 20. I'm having the interns recruited for Scala for healthcare project. We have recruited the guys from various colleges who are having the CGPA of greater than 9, and we put those members in the training, friends, actually. Okay, training. And now based on the ranges, we are having other members also, team leaders or whichever. So age is between 20 to 80, and the salary range between 35K to some 1 crore, assume that. Now, what is the problem with machine learning algorithm is, see, we are giving age and as well as the payout to our algorithm or to our model. What this model thinks is, just if you refer, if huge values are there, if higher values are there, maybe it is having high priority. It may think that this model, whatever the model you are selecting, think that, so maybe I'm having, okay, this data set is trying to give some more insight to me, and I should focus on this particular salary rather than the age. Then what is the problem with this, friends? What is the problem with this? Because your model is wrongly identifying a particular feature because of its higher values compared with the age, because age is between 20 to 80 only. And even sometimes we restrict the members up to 60 only, not more than that. Maybe in senior positions also hardly will be getting 65 or 66 aged candidates. Okay. And if you observe the salary range, because it distinct 50 lakh or 80 lakh or 1 crore like that would be there. In that case, friend, just if I'm talking about the salary, it is reaching more heights when compared with the age. Now this model interprets this particular analogy in such a way that, oh, salary is more important than age, so that it's skew to that aspect. That is skewness is a problem. Okay, that means it is feeling that okay, salary may be higher contributor compared with the age. Then how do we solve this issue, friends? What is the way? Already we have discussed. It's not a new or out of box or out of syllabus question. Okay, so this question is for all you guys. If this is the case, if some of the features are in one scale and some other features are in another scale, then how do we handle this particular situation, and how we'll convey our information or insight into the model? Because model is hardly learning, and it is getting the insights of that particular data. Some kind of the logic it follows, and it may be observing all those aspects. Now in that particular case, how do we control our model, or how do we convey the proper information about our data to the model? What is the process for that? Hint is definitely it is belong to the data pre-processing. Yeah.
You can
What is that, Venkat?
No, earlier we were talking about this in the classification. If the if it is like skewed, we have to work on the median. When we have seen about the data types, like
suppose one feature is having one kind of unit, another feature is having another kind of unit, and we have to uniform, or we have to manage that particular unit into the uniform unit. Then only the model don't mistakenly take the skewed values of your salary. I have given enough hints.
yeah, we have seen that features if features are different units. Standardization.
Yes, standardization. Now you observe here, Venkat and all the other guys, all friends, can we make use of the Z score for the standardization? Can we? Friends?
Yes.
Yeah, how we can make use?
With help of mean.
With the help of the Z score, because Z score, you know, whichever the value I am giving, if just observe that these are all the values from our data, and with the applicability of this particular Z score, that is what we have seen in case of the Z score, which provides a standard score, indicates how many standard deviations the element from the mean. That means this particular Z score in a way providing us the usage of converting the appropriate salary or age into a normal unit. Whichever the data I'm having, just it is going to convert that particular data into the normal unit. So definitely this particular Z score, if I'm asking you guys how Z score is helpful in the management of data pre-processing, just observe here, friends. If I am making use of this example, let me copy something for you rather than giving this, just to observe here, friends, which is very important thing. And from stat, if they want to twist something, and these type of questions they may ask you, the panel members can grill you if they observed like, you know, you're having little weak in the stat orientation, so they may ask this kind of thing. Because definitely we have to perform data pre-processing before launching our model. Then you should observe these kind of the aspects, friends. Okay, we cannot say that all our features are following the same kind of the scale. and it is mandatory in that case so as to maintain that particular units into a common format or in the standardization. So in that particular case, definitely we have to use the other techniques. So like if you see here, I am making use of the Z score. Okay, it doesn't mean that I have to make use of the Z score. Can someone give me what is the other technique, friends, for the making the units similar?
Normalization.
Normalization is also there. Okay, so there we have exclusively discussed actually normalization, standardization, all these things. Suresh, when you are going to talk about regression and assumptions in the regression?
Tomorrow I'll give a detail. I have note down everything. Like I made in a book. I have done everything. I just need to make a PPT.
Very good.
I'm ready. Actually. I'm ready.
You are ready.
I can talk, but it doesn't make a sense when I'm talking like it looks like I'm barking. I don't want to bark that. I want to make a meaningful bark.
No, like that, no problem. Yeah. So Venkat, what we are going to explain in the day after tomorrow, that is 31st, we have to give treat to us with your concept and explanation.
Not much in unsupervised learning. I can only speak 2 or 3 sentences.
Yeah. Then can I give you this thing, data pre-processing techniques?
Okay.
Because now Yogesh is also
you are fixing people. Yeah. Oh my.
This is interesting because if you do some mistakes again, everyone can learn.
Yeah. So no problem, because data pre-processing, that day we have seen some kind of standardization, normalization, and again we are talking about this Z score. So you can accumulate Venkat actually. So whatever the aspects we have seen, just you can go through the earlier sessions of our machine learning stuff, so that you can pull the whatever the class shell we have pasted in the Google Classroom or Drive.
This is very good. It helps me to everyone of us like to prepare for the interview.
Exactly. You pick up those kind of the points and you can do well, Venkat. Okay, so that means if you are observing your age is in between 2200 and salary is from thousands to some crores, then definitely we have to rescale the variable. So the standardization can be done with the Z score also. The main advantage here is as a process of this particular data pre-processing, we can try to rescale the variables to a common standard scale, that may be -1, -2, -3. Likewise, I need to have the common scales for age and as well as the salary, so that my model don't mistakenly observe those particular points, because they are trying to convey some other information and they are giving some high prioritized data. Okay, don't go for all those kind of things. And if you are observing, friends, one more thing, one more point, maybe Suresh can easily answer because it is his favorite aspect. How can we detect the outliers or extreme values? Because he has some thumb rule actually. Whenever I am saying that measure, he immediately says, yeah, that measure is there, definitely outlier this is. They like that.
I'll be relating it with a mean actually.
Very good. That's it. Mean. And one more thing, standard deviation. See,
standard deviation is dependent on mean only.
Mean only. Yeah, but now see here, earlier we may have some kind of the doubt actually, like how mean and standard deviation. Now with the help of our empirical formula, with the help of
both are related. So standard deviation is dependent on mean.
That's it, friends. Okay, so very simple. While working with the outliers, or if you want to observe your data is presenting the outliers or extreme kind of the things, mu and standard deviation for outlier detection. That means if you are getting more standard deviation, maybe 100 standard deviation or 200 standard deviation, what you can say, definitely that is behaving some odd, some distinctly it is behaving, so that you can catch hold of your data and you can revise that thing. Apart from this, friends, what is the other technique we have used in the outliers detection? What is the other technique we have seen in the outlier in the grounds of I can say because three different things are there now in the entire stats. What is the first one? About your mean, median, and mode. Second one discuss about the range,
dispersion,
percentile,
variance,
covariance, correlation. What is the third one, friends? It is discussing about the skewness and kurtosis. Okay, now I'm giving a hint. In the second zoner, in the dispersion zoner, we are having the technique of the outlier detection. Apart from the mean and standard deviation, one more measure is also helping us so as to observe the outliers. What is that?
So variance.
correlation.
Correlation.
Correlation. Percentile. Okay.
What is that percentile? Can someone help me, friends, to understand that again? Percentile that day we have computed na 25 percentile and 50 percentile. First quartile, second quartile, third quartile kind of thing. What they have given actually, the computing of the percentile has given that whichever the values present in the corresponding distribution, it is giving us to understand the percentile and how the data is distributed among these kind of the
but
percentile.
one thing here, when you're going to the, I'm now getting back that percentile. On the day you told that you are giving a break even of 25%, this one 50%, this one 25%.
Okay, correct.
So, okay, in that break even, okay, if it falls under that, because outliers cannot, you can eliminate outliers from this actually.
That is what we are not only observing the outliers, but from the percentile you can find out them where I got this, whether
you told this word also. Exactly. I remember now. You said you can find out easily because you asked me a question on that day that in a mean you can just see the outliers are there, but how to identify an outlier is using percentile.
Very good. That's it. Good.
The location, it will find out the location.
Very good, friends. So now what exactly Z score? What is the conclusion for the Z score, friends? Can someone help me? Z score can be known as a standard score and which is used to standardize, which is used to fix up the scale, okay, for the appropriate features or values. And I can make use of this Z score for my data pre-processing. Okay, and to standardize the appropriate features. Okay, that is the first thing. Now I am introducing you one more score called T score actually. Okay, T test or T score. Sometimes, you know, friends, there is a possibility of we are not aware of the population and we don't know the standard deviation of the corresponding population, and we are completely working on the sample data only. Okay, observe here, the point is not aware of population standard deviation. We are having only some sample data, some kind of the sample info. Maybe for the sample info, I'm having the mean value and I'm having the standard deviation value and I'm having the number of samples also. Now, the understanding is very simple, friends. If your distribution is providing you the population standard deviation, better you go with the Z score. Suppose you are working in a scenario like the data, we are not having the complete narration of the population. Can someone help me, friends? What is the difference between population and sample? Again, maybe.
Sample is a subset of population.
Very good. Or
Which,
subportion or
which get
subset
all
of
the
the
characteristics.
subset
Which
of the.
inherit all the characteristics of the population.
Yeah, very good. Sample should reflect. Okay, it should reflect the characteristics of the population. Now, one more important point, friends. Here, there we have seen some random sampling. Second one is the stratified sampling. Third one is the cluster sampling. Friends, you have to remember this thing. Okay, maybe you are, if you are not aware of the procedure or thing, but still at least one or two techniques you should know. Okay, and this particular sample information only I am knowing. Okay, in that particular case, you can go ahead with the t-score, friends. Okay, t-score you can make use whenever you are knowing the sample average and you are knowing the population mean, and if you are knowing about the sample standard deviation, and of course you are aware of the sample size also. Okay, but we are not having the standard deviation of your population. Of course, population mean also you are knowing, and but we are not aware of that population standard deviation. So in that particular case, you can elect this particular t-score. Okay, now let me give you this formula for you guys. So this particular t-score, you need not, as mentioned earlier, you need not worry about the formulas and all. Obviously, your Python is providing this kind of the summary statistics. You can directly refer the t-score there. Okay, and with the, just if I'm making up the summary of my model, okay, obviously I'll be getting my Z score, I'll be getting my t-score value or F score. Okay, all these things automatically referenced by our Python. Now you tell me, what is this X bar?
Mean.
Which mean? Sample mean, na? Okay. What is your mu naught?
Population mean.
Very good. What is your S, friends?
So,
Sample standard deviation. What do you mean by population standard deviation, friends? Always referred by sigma. If you see the Z score, if you are seeing the Z score, what it refers Z score actually, if you see the formula of the Z score, little up I am going. Oh, did I mention Z score formula? Yeah, here. So X minus mu by sigma. Okay, that means this we are having individual value, we are having mean value, we are having the standard deviation also we are having. Whereas in this particular t-score, in the computing of the t-score, as we are not having the standard deviation of the population, you can go with the t-score. And what do you mean by this n value, by the way?
Number of samples.
Okay, because this is also playing a vital role. So based on this particular convention, you can refer the t-score. Okay, so when you are not aware of the population standard deviation, and if you are not working, you are working on a sample data, and then you need to go with the t-score. So these particular values. So now if you refer the comparison between Z score and as well as the t-score, have a look on this diagram, friends. When you can use the Z score and when you can use the t-score value. So the statement is like this. Do you know the population standard deviation? If it is yes, and if the sample size is greater than 30, then go with the Z score. That means your Z score demand is that sample size must be greater than 30. This is the first condition. Second important thing is you should know the population standard deviation. This is the Z score requirement. Whereas if your T score rescue you, okay, come to rescue you in such a situation where your sample size is very less, friends. Sample size is very less, and you are not aware of population standard deviation. Okay, then you can bank on this T score. And of course, by using that particular convention, you can mention the usage of the Z score and as well as the T score notations. Okay, simple. suppose if you are aware of, but you know, friends, only the point is at the moment I am talking about the Z score and T score. Only the convention is why I have introduced this Z score for you is for the sake of the standardization, friends, actually. For the sake of the standardization, because in the pre-processing, data pre-processing technique, you can make use of the Z score and T score. I don't think, friends, here if you are having only less than 30 samples, do you feel does it make sense of applying to model, friends? Only 30 samples we are having. And something like, you know, one important observation we have seen that day in the beginning, supervised, unsupervised, and semi-supervised. Can someone relate this particular semi-supervised with our discussion, friends? Supervised we know because we are having all the labels and all the historical data. Unsupervised is a distinct kind of thing, like we don't have any history and no labels also. We need to find out the patterns and insights of that particular data. Then to which category you can observe the semi-supervised? My internet is working. Friends, am I audible?
Yeah, you are audible.
Oh, very good.
100%.
100%. Very much audible. Now you tell me, friends, where do we use this semi-supervised? Of course, as the name implies, it definitely belongs to the supervised category. But if you are having very less historical data, your data is very less, friends, very handy, and it is not providing you much results, then whether it is going to suffer with overfitting or underfitting?
Overfitting.
Overfitting. Why?
Because if you get more data, it will lose its confidence.
More data we are having, it learns more.
More data, then it will learn more. If you have a less data, if you're getting new data, no, this guy is gone.
It is only by hearting. Less data means it is not going to learn. It is not learning anything. Definitely, yeah, it is by heading. That's all. So that is what how you can refer the semi-supervised. Now, then how do we correlate the semi-supervised in the above mentioned with the T-score? Because T-score, you know, where you can have very less data, because my sample size is very less, I cannot make use of Z-score. In that particular case, very rare case, friends. Even I have not seen any kind of such case. Okay, at least I will be having 1,000 records, at least. Okay, so there is no chance of giving 30 records or 10 records or something like that in the reality. But however, just to have a look on that T-score value also. Now, at the moment, I am talking about the analysis of variance. Can someone help me, friend? What do you mean by that, Anova? Very, very important. Anova technique. This is the third concept we are discussing. What do you mean by analysis of variance? Let me give this diagram so that you can easily correlate. Yeah, have a look on this, friends. So here what it is saying is, if I'm referencing this particular Anova kind of the technique, it is a statistical technique that is used to check if means of two or more groups are significantly different from each other. Okay, so I'm having the representation of one distribution and I'm having another distribution. And if I want to check if the means of two or more groups are significantly distinct from each other, okay, that is what you call the analysis of variance. Okay, just it is helping us to check the impact of one or more factors by comparing the means of different samples. Here, if you see, friends, here I'm having some sample 1, sample 2 and as well as the sample 3 kind of thing. And of course, distinct features I'm comparing. If I'm taking the one-way ANOVA, so my economical status, body mass index, whether there is any effect of economical status on body mass index, whether the guys are upper middle class family and do they really have any impact on body mass index. And thereafter we are pulling this age and as well as these things, whether really age and these things are having the BMI effect on BMI or not. Third important point is we are making use of another feature. This is age, economical state, I mean social status and diet. If I am mixing up these three kind of things and we are verifying this particular BMI, whether really this particular thing is really impacting the other things. Okay, so just if you are referencing this example, friends, this ANOVA is computing the means of different distributions or different possibilities, and it is trying to give a fair understanding of whether really these particular things are distinct or whether they are having any importance to consider. Okay, so now I'm having some different samples, friends. Sample 1, 2, 3. Now, what is your thought process? Suppose I'm having sample 1, I'm having mean 1. Sample 2, I'm having mean 2. Sample 3, I'm having mean 3. Now, what is the approach we need to follow so as to observe whether these means are distinct or not? Any specific procedure is there, friend, for that? Just to think through. We are having multiple samples. Of course, we know that each sample is having mean. Just we can compute the mean without any doubt. Now, how ANOVA is fetching this particular thing? Not only the sample mean, but also some other aspects are also there. How it is going to refer? Have a look on this, friend. Just I am revealing the secret behind that. If you observe the point here, okay, just have a look on this. This point helps us to understand. Observe here, mean is the sum of values divided by the count. We know that. Suppose sample 1 is having some 10 numbers and all those numbers up to 10 can be calculated. And similarly, the second one and third mean also we can compute. So it is divided in a simple arithmetic average of a range of values. Okay. And ANOVA fetches two kind of the mean, friend. One is a sample mean. That means mean of all observations within a sample. That means S1 mean, S2 mean and S3 mean we are having. And important point here is, friend, grand mean. Mean of all samples or mean of all observations irrespective of the sample. What do you mean by that, friends? Can someone elaborate that? How can you refer the grand mean?
No, all the three combine.
That means we are combining all S1, S2, S3 and we are going to divide those by 3, which obviously says that the grand mean we are having and we are having our sample mean also. So by observing these kind of the aspects, one can easily says that how our samples, whether these particular samples are really distinct. You know, friends, any point is striking to your mind at this moment, because I am talking about the samples and similarities. Any similar concept we have seen earlier? Means, mean 1, mean 2, mean 3.
We will see the variance using correlation.
Okay, so because ANOVA, what it does, friends, actually ANOVA is nothing but which is doing observation of all the samples, and it is whether two groups are significantly different from each other. One more point, if you observe the covariance in the earlier session also I referred these, friends. High correlation, low variance. Another important thing, now what we are seeing, our ANOVA is also helping us whether these particular things, like, you know, check if means of two groups are significantly different or not. S1, S2, S3, different or not. Now you observe here, friends, we are having two set of the interview panels, and one set of the interview panel, average of the members is 5 rating. Second panel has given the 7 rating. Now you see, suppose if I am getting same 5 rating here, recruiting of these particular two panel peoples really make any difference, friends? Assume that is a parallel recruitment. I am doing my interviews with my panel, and Suresh and Venkat are doing their own interview there on their pace, and where both were given 5 rating for the same kind of the candidates. Like here 10 members we have interviewed, and here 10 members, but out of these 10 we need 10 members only. This is one scenario. Whereas I have given 5 main, and Suresh and Venkat team has given 8 main. Automatically the recruiter is taking this one only now, because average mean is greater. Here the really the members performed well. All those members compared with these persons, they are having greater capacity. Okay. Similarly, Anova helps us so as to observe the correlation and variance values related to these aspects. Okay, so that is how you can refer your observation related to Anova. Now, as a conclusive part, friend, just I am introducing you one more aspect, which is nothing but very, very important: chi-square test. Now, friends, observe here. In case of your Z score, T score, Anova, what is a common point? Tell me whether we are working with the numericals or categorical.
Numericals.
Numericals. All your Z score, T,
Because you're going with the means everywhere.
Means everywhere. But what happened if my data is containing the categorical? Then what do? I cannot apply Z, T, or F or Anova. Then in that particular case, you have to apply the chi-square test. And one more important thing, friends, chi-square directly we are going to use in the decision trees actually. So your decision trees, okay, dependent on this particular chi-square, and of course some other measures are also there. But one of our decision tree model is dependent on this particular chi-square test, which is the decision tree kind of the aspect. And the chi-square test, what it does is it is observing that how categorical values are related. That means, you know, which is comparing two variables in a table and to see if they are really related. That means in a more general sense, it is testing whether the distribution of the categorical values are distinct from each other or not. That is what you can say. The I'm giving you one more thing, friends, actually here: observed value and expected value. Which is the original and which is the computed value, friends?
Observed value is original, expected is
value is a computed value.
computed.
Expected or observed?
Expected.
Expected means existing, na? Expected means existing, or observed is existing?
Observe is what we are outcome. Okay. Yeah.
Computing. Observation means we are observing. We are generating. Whereas expected means already there. Expected means what? Already something is there in our mind, and we are okay. We are stick to that. Okay, so that is what how you can refer, and the differentiation between these two things can be observed in the chi-square test. Okay, so our chi-square test, there is a simple formula, friends: observed value minus expected value, and just this particular expected value. Okay, how these values are correlated and how we are going to handle those kind of things. Okay, so this is what I want to explain in this session. Okay, however, Again, chi-square test we are going to work out in the discussion of the decision tree. But I want to give a glance of these particular tests actually. So can someone help me to observe which are all the key takeaways of this session? Where we have started basically?
Statistical test, Z-score.
Before that Z-score, we have seen some distributions, some kind of distributions. And there we have checked whether two distributions are equal or not.
Non-normal.
Equal or not. And here we have used our empirical rule so as to check whether the corresponding to whatever the distributions we have given are equal or not. Those things we have seen. The second thing we have introduced the aspect of the Z-score, which is basically used to
Data preprocessing technique.
Preprocessing and which is standardization. Okay, so just it is providing the standard kind of the aspects to convert the appropriate values into the standardization. What is the third thing, friends? Actually, T-score. When can we use the T-score? Less sample,
Population standard deviation.
less sample, and no population.
No population standard deviation.
Very good. Okay, and that we have seen. And what is the next thing, friends? We have discussed Anova, which is the analysis of variance. So we have seen some multiple samples we are having there. We are having some means also. So by observing the local mean and as well as the global mean, one can easily observe the distinctions of the mean. And the fifth aspect, of course, which is the chi-square. What is the specialty of this chi-square test, friends? Which works on the categorical base of the data, and especially in the decision tree models. Okay, you can bank on these kind of the chi-square test. Okay, so that's all, guys. And for tomorrow's session, however, the very first aspect is Suresh is going to talk about regression and as well as the assumptions. Okay, and then I'm going to refresh all your machine learning kind of the algorithms once more. Okay, and that is the point of objectives for the tomorrow session. Okay, that's all, guys, and see you back.
Thanks, Uma.
Thank
You
you.
were talking that the what is it? The perspectives. Now what happens? We become so stressed because I'm searching for some jobs, and sometimes I get tempted and see for data analysis. I wanted to bring this, the way you talk about this stack up, the stack up thing that fellow was saying, stack up data. So I'm like kind of mad. And yesterday I thought, okay, I think we need to do some more research and we talk.
Yeah, one important.
We get stressed out.
No problem. No need. Simply see, companies, researchers and all, their wish is different, Venkat. We are machine learning engineers or data scientists. What we'll do is we are making use of existing things, and we try our level best in the context of the hyperparameter tuning and all. Generally, a student initially joins, he in the first semester of his BTech, what he feels, I need to prepare all the 6 subjects and 3 labs perfectly. I should aim for 100% marks. And later in the second semester, end of the second semester, he realized that, oh, no problem. I can get 9 CGPA so that I can crack Amazon or Facebook kind of thing. Okay, I'm not discouraging. Only the thing is the relevance you see. Because what is your relevancy? Maybe if you want to become researcher, definitely encourage to go and crack the Kaggle. No doubt about that.
Even myself and Suresh were talking about that from long time. Once we get inside, it will not be interview will be a difficult thing. But once we get it, we will not be doing complete. We
will be doing these things only. SciPy, import SVM, import KNN, import.
We'll also have support of some experts,
definitely, because you are not the one who is leading the entire things, because that too, one more thing.
We have to get inside that, then of course we get support from some
definitely
team. We will always do some part of the work,
that's it. Not everything. Yeah, very good, guys. That's all. Okay, thank you. See you back.
Uma.
Thank you, sir.
Thank you.
Uma, one thing.
Tell me. Already I have overboarded. I'm having one more.
No, not about this. Not about this.
Uh,
Actually, what is your perceivance of what you have gone through 30 classes with us, and the way we are answering to you? Um, what exactly you think that where we are standing? How much percentage and how much work we have to do more?
in that case, I need to
Be frank,
say,
no problem. If you say
yeah.
I'm zero, I'm zero.
No.
I can take it.
Yeah. In that case, Suresh, actually, I need to assess. I thought of doing that. Um, let me put in this way. I'll conduct some mock kind of the test or interview aspect, and you should be very precise and you should be very concise, because the see one important point I want to reveal to you. If you are explaining more, and you will be asked more questions, no doubt about that. See, even in my case also, if any person I'm interviewing, he's explaining more things and unnecessarily he is pulling all the subject matters, then I will be getting more chance. Now I need not depend on my mind, because himself he's entering into the net of the interview and he's pulling many aspects into the interview. Then obviously you are making yourself complex thing, that I can say. But see, to the point actually. So to the point strictly, okay, if Lakshmi or Yogesh, if you see Venkat also, there you are very good at subject, no doubt about that. Only the point is you are explaining more, Suresh. That obviously after joining, you should be like that only. See, after joining in the team, definitely your role is more, I think, because you have more storytelling, and in front of client, they will pull you and you explain. That's what I said. But whereas for the interview, exactly Lakshmi, Yogesh, and Venkat, these members are very suitable, because if you are talking more, obviously they feel that, oh, this guy is knowing more than me, then why I should recruit? Maybe he will be getting some other like that they feel. Okay, not always, but sometimes. But why simply we ourselves we are dragging into those kind of problems and explaining more aspects? Always you think through, and that really helps you, Suresh. Okay, right.
No, actually, Uma, what has happened is such a 13 to 15 years experience. We have been used to that.
Yeah,
Come
because
out of that, it will take some time. Precise things. Yes, what you say is 100% correct. I'm a storyteller. Yes, 100%
storyteller,
correct.
because your candidature is 100% suits to landscape of the data science and machine learning, but only after joining, Suresh, you have to hold something. Definitely you are having that vast experience and you can connect dots easily to any scenario. That definitely helps you. But only my suggestion would be, as a friend, as a well-wisher, and only you stick to you, but even I have not observed that, to be frank, out of these but in class generally you need more explanation, likewise you are doing. But whereas if I am putting some instant test or some instant questionnaire, if I am giving to you, and you take this scenario and explain in 5 minutes or 10 minutes, then I can analyze you guys. Okay, definitely in future, definitely I will take that opportunity, and we'll
Yeah,
talk.
once actually, Uma, once you start with the implementation, if after 1 2 implementations, it will be right time for you to test people that how much
Exactly.
because that is the most important.
Exactly. Because
You should know.
we are traveling, whether we are traveling in a right direction or whether our
We are traveling in the right direction.
right direction, and whether our preparation is enough or not, I have to test you. Okay.
Yes.
Definitely
You need to know. You need to know.
but you are up to the mark, Suresh and Venkat, Yogesh. These guys up to the mark, because the way you are explaining, and without knowing how you explain, never know, you cannot, because yeah,
No,
without,
these are the new topics here. These are the new topics actually, and
but
which is
still,
really
but still you are popping up, na? That is the beauty. Yeah, definitely, Suresh. You can crack second or third interview. You are definitely going to crack with your experience. But only the thing is little bit, just you are curious and based on your knowledge, and for your candidates, they even don't expect the coding also, Suresh, to be frank. Only your storytelling capabilities and how you are able to connect the dots and how we are helping the members to take the decisions. Especially you focus on data pre-processing, standardization and normalization, feature engineering, those things, Suresh, because there the people are suffer a lot. Because once that is over, then the member who is having 5 to 10 years experience, they can handle the model. Never. That is not a me. But your capacity is to handle the pre-processing and how to prepare the data for the suitable to the model. These things really you are having more scope. Definitely, the company needs you.
See the difference from Monday. I'll be like a precise like Venkat. I'll try to become like
because Venkat has given a nice. I don't know whether you have trained or
he actually is coming to the point.
That's what I observed.
Uma, after the class we both discussed actually.
Oh, is it very good?
Yeah, both discussed, and at the points but my nature and my experience, when I want to understand myself, I go with the storytelling.
That is good. That's a context I have told. Already we have seen context. Once you enter into the team, your services are more important than Venkat, because Venkat cannot tell the stories and he cannot face the client. But you can. Venkat easily crack the interview because he is very precise, and they feel that. And even I also, if some people, if I'm asking the questions, he is telling 1 or 2 lines. That's all. Oh, this guy is very experienced and he's not even talking more. The context I'm saying. Okay. So no problem, Venkat. We will do some good work and definitely will have that capacity of cracking all that. Okay. Right. Okay. See you back. Thank you. Bye. Bye.